Chapter 0, Section 0.3, Exponential and Logarithmic Equations. So we will learn solving exponential equations and how to solve logarithmic equations. Now this is an example of exponential equation. We will have an exponential term here and another number here or another exponential term. This type of equations are called exponential equations. Now, we basically use two properties of exponential and logarithm for solving exponential equations. This is a one-to-one property of exponential functions. If b to x is equal to b to y, then x is equal to y. So this type of property will be used in such questions. Let's say, for example, if it is like 2x minus 1, and what do you get for x? Or you can change it to the base. Okay, there will be some question like this, for example. You can change this base to 2, and then you will have like 2 to 4x minus 2 and 2 to x. So then this property will tell us the powers are same as long as the bases are same. And the other property is the inverse property. The inverse property, you can take it as, think of this way. You have b to x, and if you want to get rid of the log, okay, this is equal to c, then you don't want you want to get rid of b. Now basically you take the logarithm base b of both sides, and this will cancel out these b terms, and then we end up with this. This is x is equal to log base b of c. So the idea is to bring the log base b to both sides and to get rid of the logarithm on the to bring the x down in the exponential. Now, here is a strategy for solving such problems. I mean, if two sides of the equation do not have the same base, change them to the same base if possible. Then use this property. Okay. Otherwise, if not, I mean, you can use the inverse property basically. Now let's see these examples here. So we want to solve these equations using one-to-one property. Now here this is 5 to x is equal to 5 cubed. So you can clearly say x equal to 3. And now here 2 to 3 minus x is equal to 2 to the 4th. So we know this is 16 is 2 to the 4th. So these are the bases are same. So 3 minus x is equal to 4. So x is equal to minus 1. I mean, you can say anyway, you can do this. And here 9, as you see, 9 and 27, they're not same base. So in this case, we check if they can be written as a power of the same number. So it is obvious that this can be written as 3 squared, and we know 27 is 3 cubed. So now we can write it this way. And now you know the property of exponentials. If you have the power of powers, so you can multiply them like this. So now we have to multiply the powers here. So let's multiply them. It will be 3, 2 times this. It will be 4x minus 6. And this will be here 3 to 3x plus 3. Now we can multiply. And then the powers are same as you see here. I mean, the bases are same, so the powers are same. Then use this property. So we will get 4x minus 6 equal to 3x plus 3. And if you solve it, you will get x equal to 9. And when it comes to the last one, We can. Okay, we can do the same here. The only thing you have to do is, this is 3 over 5. This is the base is 3 over 5, but here this is not 3 over 5. The question, the first thing you can do is, like, if you can, to write this one as a power of 3 over 5. So then when you write this one, so we don't know it yet, okay, we know, then you can write this one as this way, then the bases will be same, then you can make the power same, I mean equal to each other, then solve the equation. Now the idea is, I mean, what is 3 over 5, which power of 3 over 5 is 25 over 9? Okay, it's better we analyze 25 over 9. The first thing is, it's the 5 over 3 squared. And what can we write this one as a power of, I mean, 5 over 3? I mean 3 over 5? Yes, we can. So we can write this one as, 5 over 3 can be written as 1 over 3 over 5, which is negative first power of 3 over 5. So I can write here, instead of this one here, instead of 3 over 5 over 3, I can write here 3 over 5 to negative first power, and then squared. Then you know the property here. If you're taking the power of power, then you can multiply them and write it as the power of the base. So this is minus 2. Now we have this one then. We have this equality. We have two terms, two exponential terms, and with the same base. Now, what does it imply if the bases are same? So the exponent should be same. So it gives us x equal to minus 3. Okay, let's see how it goes here in the slides. Okay. Yes, as we did, it's the same. Now let's solve this triangle exercise. Now 4 and 8, you can write this one as 2 squared. We want to write them in this in the same base. So this is 2 squared and this is 2 cubed, obviously. And then we multiply the powers here, 4x minus 6 equal to 3x plus 3. And here you see the bases are same now. I can use this one-to-one rule. It's if the bases are same, then the powers should be same. Then when we solve this one, we'll get x equal to 9. So you can write it this way, or the solution set is, you can say it's 9. Now, we might have different bases. So in this, if we are given an equality of two exponential with different bases, we can use logarithm now. Now, how can we use the logarithm? We can take the logarithm of both sides, like common log base 10, or we can use ln of both sides. So it means the ln base of ln base e, a log base e, or logarithm with base of the exponential. So what I mean here is, for example, it's telling 3 things here. So you have 2x is equal to 5, to 2x. Now, one way is to take the log of both sides. And what does it bring to us? It brings to us, by using the property of the logarithm, it will bring the x before log 2, and then we will end up with this. Sorry, log 2 base 2. I mean, not base 2, log 2, then x will be log base 5 log, I mean not base, or it's log, this is common logarithm, so it's log base 10. So this is one solution, and let's do the same thing with ln. So we could take the ln of both sides. So by the property of logarithm, you can have this x ln 2, ln 5, and x will end up with ln 5 over ln 2. And you need this is mathematically same as the previous one. And the last thing it says is you can take the logarithm with respect to, I mean, with base 2. Okay, let's do it. Like log base 2, log base 2. You're taking the log base 2 of both sides, and then there will be this cancellation. You end up with the log base 2 of 5. And is it same as this? Yes, we have such property. We didn't mention it in this powers. You don't need it in the property. We didn't mention it. You don't have to use it, but you can directly use this one. Or I mean, if you use calculator, you will see all of them are same. Now let's look at this problem here. How can we solve it? We basically, okay, how can you get rid of e here? What we have is the shortcut here is directly use logarithm base e of both sides. So why? Because of this cancellation here. Log e means, ln. Log base e means ln. 67, and we can use calculator find the answer up to 3 decimal places. Now, okay, I will show the answer in the slide, but let's do the other one first. Okay, for example, for this one, if you want to get rid of 5, the best thing you can do is to take the logarithm with base 5 of both sides. For example, you have this. Now I don't want this 5, so take the logarithm base 5 of these numbers on both sides. Then I have this. To do this one, be careful. It has to be like 5 2 something, okay? So it will be log 5 35. Add 1 to both sides or send it to the other side. So then it will be plus, and then divide by 2. Now you will see this is this. Log base 5 to 5 plus 1. Now this whole thing is, separate than 1. So sometimes, writing makes confusion. But this whole thing is one thing. This is just another number. We add them and divide by 2. So this will get you. This is 2x, and we divide it by 2, you see. So now x is equal to this one. Now I want to show the numerical answer. So first you check the logarithm of both sides. Here, what I did here is done by log base e again. So this log base e means this ln here. So it will be x. So x is equal to ln 167. Now, if you use a calculator, you can get this approximation. And now take the logarithm with base 5. So take the logarithm of base 5, both sides, and then this 5 and 5 cancel out. We have this one. And then solve for x. I mean, you can add here 1. I mean, it's better to write it here, because in this way, someone get confused, like, they will think of this way now. So it's 1 plus log base 5 of 35 divided by 2. If you use calculator, you will get this. Now let's try and check. Be careful here. This -1 is not in the power. It's just here. So first thing is to isolate the exponential term. 4 to 3x is equal to 8 plus 1, which makes 9. So 4 to 3x. How can I get rid of 4? You take the logarithm base 4 of both sides. And now this log 4 and 4, they cancel each other. Got this one, 3x equal to log base 4 of 9. And now divide by 3. We end up with this x equal to that number here. And we can approximate it, this one. I mean, if we have a calculator, we can get it. I'm not sure what the answer is, so I will not check, but we can approximate my answer. I mean, if you find the answer, for example, like 0.35678, so if it is 4 decimal numbers, we take the first 4 to look at here. If it is 5 or bigger, we raise it to the 7, 8. So then we write this one here. This is rounding the number, you can call it. Like we generally will ask you to find the solution exactly. I mean, exact solution. When we say exact solution, it's this. We will not ask you the numerical solutions. Now find the x-intercept of the function. Now let's see what is the x-intercept of this function here. You can write it as this way. Instead of f of x, you can write y. Then to find the x-intercept, you set y equal to 0 and have 0 equal to 3 for x minus 3, 7. Then send 7 to the other side, and you got this one. Now, what you can do here is take the log of both sides, log base 3 of both sides. And add or send this one to the other side as plus. So here we get this one plus 3 and divide by 4. So the x-intercept will be this number here. Okay, let's see how it's solved in the slides. Same. Now let's solve this problem. Solve the equation, exponential equation 5 to x plus 1 equal to 6 to 2x, then approximate the answers to 4 decimal places. Now there are several ways of solving it. Okay, the first way is using the base of 5. So what you can do here is take the log base 5 of both sides. Now, this will bring a cancellation here. But this one here, using the property of logarithm, okay, remember the property of logarithm. Log base b of m to p is equal to p times log base b of m. So it means like you can take this p to the front. And now this is the power here, so you can take it to front. You'll get it 2x times log base b base 5 base 5 of 6. Now after this, you will solve for x. So this question comes to, okay, this you can take this one as just a number, okay? So if I ask you to do it this way, what would you do? X, A. Now, how do you solve this one? You collect all A's, all X is one side, then 1 is the other side, then you take the X as a common factor, and you divide both sides with 2A minus 1, and then get X, So you have to treat this one as a number. This is a number, okay? It's just a number like A here. It can be, but it is written in terms of log. So don't let it confuse you. This is just a number. If I put A there, it would be A. Now, what do you get? Like, how do you solve an equation of such thing? So just collect all X terms one side. Now, send X to the other side, you get 1, and take X as a common factor, right? And then this makes 1. So divide it by this term here, log base 5, 6 minus 1, and then 2 log base 6 minus 1. So after the cancellation, you will get this one here. So this is the answer here. Now, this is one way of doing it. The second way is you can start from 6. So it means you can take the log of 6 both sides. Log base 6 of both sides. And in this case, this will be 2x, and you will have x plus 1 times log base 6, 5. You multiply like this one, sorry. You multiply with this number here above. Sorry. Then you know what to do. Send this one to the other side, and you will end up with this. I'm writing it like x will go there, and x will be a common factor, and you will end up with this. Okay, please, if you can't see it, stop the video and try to do it yourself, and divide both sides with 2 minus log base 6 of 5. Now we have this answer. Is this answer the same as the previous one? Yes, not same in the look, in the appearance, but mathematically it's exactly the same things. You can use a calculator to see it, or they are same mathematically. They're same, exactly the same. It's because of the properties of the logarithm. You might have always you can use any base to express. You can express a number in any base by using logarithm. Now, a third way is this one. Take the log of both sides. So it means log base 10. So the good part here is it will bring 2x and x plus 1 down. So then you have to deal with this one. And the rest, the rest, it will be 2x log 6 minus log 5x. No, sorry, this is x times log 5. And then it's log 5. Then take x as 2 log 6 minus log 5. And log 5, divide both sides. You get something like x equal to some number. here 2 log 6 minus log 5. Is this the solution also? Yes, it's another way to write the solution. Now, can we use a logarithm of another base? Like we used base 5, 6, 10, and how about using log ln, log base e? Okay, here in the solution it uses ln. Look at here. This is the fourth way of solving it, let's say, a fourth way. Now look at here. Just take the ln of both sides. This is just logarithm base e. And then it brings x plus 1, here down, and a 2x here. And then what's next? So you have to multiply and distribute and collect x terms one side. So send this one to the other side, you see. Okay, it takes, okay, what it here does is like brings this one here and send this one to the other side. Okay, it's okay. So then we have this common factor here, x. So it should write x times this one and divide both sides with ln 5 minus 2 ln 6 and like ln 5 minus 2 ln 6. Then it will give us this one. I mean, if you can do like take this minus here, make it minus, so it will change the answer as like ln 5 over ln 5 minus ln 5 plus 2 ln 6. I mean, you can do it, if it is minus a or b, you can take this minus here, like a over minus b. You can use it here. Okay, anyway, if it is an essay problem, you can just leave it as it is. But if it is a multiple choice question, then you might have to do some more work and to see which of the choices is equal to that one. Now we use some calculator to see the approximation of this number here. You can use a calculator, it's this one. Now, solving logarithmic equations. Logarithmic equations are this type of equations. There's always a log in it, okay? Basically, we call it log because there's a log inside. Now, the main properties to solve the logarithmic equation. One is one-to-one property. If you have the same base in both sides, then if they're equal, then you can say these numbers are equal then. So in which, okay, where can we use such thing, like, for example, log base 2 of x is equal to log base 2 of x squared plus, let's say, 5 here. Okay, what do you use here? I mean, you can directly say, hey, these are same logarithms, bases are same, so you can directly say x is equal to x squared plus 5, and then solve the rest. Now, the other property here is this one here, the inverse. So this property is very important. I mean, they're both important, but here this one is like a shortcut. And the shortcut is like this. You have some log base b of some number here. So it's asking log base 5 of x is equal to 9. So what is x? So you can think of it. But the idea is raise them to power 5. So raise them to this base. They will cancel out and you will get x equal to 5 to the 9th power. So you can see this one like b, log base b, and it's x. You can do this cancellation. Now, this is the general strategy. So we will use the properties of logarithms to write the equation as a isolated single logarithm. So we will try to write like log x, everything here, then the number without x, or the terms without x, the other side. And then we will change the logarithm to exponential form, then we will solve the resulting equation. And the important thing here is we check the solutions. We check them. In the exponential equations, we never check the solutions because when it is a power, all numbers are accepted, like negative or positive. But if it is logarithm, you cannot have something negative inside. No, it's not accepted. Accepted. Sorry. Now let's look at this question here. The first thing you have to do is like to combine them because we have the same base ln. It means log base e, and then try to write something like ln of something is equal to ln of something. So then we will say they're same. Now, how can we put them together? These two. We use the property of logarithm if we have addition and the bases are same, so we can write the inside as product 2 times 3 over 2 and 6 is equal to, and take 2 to the other side so we can get this ln here. Okay, so this will be minus x squared, so we take this 2 to here, and now we have ln both sides. Now we can say they're same. It means the insides are same here. So 2 times 3 over 2 minus x and minus x squared, which is x squared indeed. They're same, so we multiply. It means 3 minus 2x equal to x squared, and x squared plus 2x is minus 3 equal to 0. Now the question is, how do we solve such thing? We can use factorization, we can use quadratic formula, whatever you like you can use. Now let's see. The same steps are repeated here in this in the slide. So we combine them first, then we have ln both sides, and then we say since they have the same logarithm, so the insides should be same. So then we use some algebra and find the solutions. Okay, let's come to here. Are we done with the solutions? No, we have to check the solutions in the logarithm. This is one of the important things. You have to check the solutions. Now let's check the solution here. How? We put this minus 3 inside the original equation. Okay, so this is the important thing. I have to emphasize this. In the original equation, not here, no, it's just here. Okay, let's do it. We put them here. It's minus 3 here, minus, so everything positive here. Positive, yes, positive, no problem. All terms are okay. So this doesn't make a problem in the original equation. It's a solution. Now let's put 1 in the original equation. I want to show it to you. ln 2 plus ln 3 over 2 minus 1 equal to 2 times ln minus 1. You see? Here, positive. This is 0.5 positive. This negative. So ln is undefined here. For negative numbers, logarithm is not defined. So this is a wrong equality. This is not true. So we say this minus 1 is an extraneous solution. It's not a solution because here we have an undefined term inside the equality. So this is, now we eliminate x equal to 1 and we just say the real solution, the one solution, the only solution is -3. Now let's do this try and check exercise. Now look at here. We have ln, and ln 2x. Okay, I can combine them and do something like this, ln. Okay, I want to do ln of ln equal to ln. Now I'm using this property of addition means multiplication. And here too, I could take it as power. I will take it as a power 2x. Now we have both sides, ln, and they're the same logarithms of base e, so they're same. So I can eliminate them directly, and I say so these are equal then. So it will be 4x minus 7 times x plus 2 equal to 4x squared, right? This is 2x squared means 4x squared. So then now this is 4x squared. You can do this job. That will be 8x minus 7x minus 14 is equal to 4x squared. And we can send this one to here, and it will be 0. This one will be x, and x minus 14 equal to 0. And here x is equal to 14 now. Now let's check the 14 in the original equation. Now let's check. Now let's see. ln 4 times 14 minus 7. Positive, for sure. Good. Now this one here. ln 14 plus 2. Positive. Good. 2x. It's just 2 times 14. 28. Positive. We only check the positivity. This might make a problem in the equations. Otherwise, like the ln, if you try to make it like, hey, is ln 16 is equal to like ln plus, this is what is this, 49 maybe? 49. This whole thing is 49 maybe. And then how can you check this one? You have to use a calculator. We don't check this one. We just check positive. Do we have all positive inside the ln? Yes. So this makes a solution, and only solution. Now let's look at this question here. To solve the logarithmic equation, and we have log and log here. There's no log here. You see, there's no log. So we have to be careful now. The first thing is, we try to reduce the number of the logs with x into one single logarithm. So write it in one single logarithm, this side. So can we do it? Yes. How can we do it? We use the property of addition. So x times x plus 3. Now we have the log. Now the important thing here is you have to check the base. The base is 10, so you can directly do this way. This is log base 10 of x times x plus 3. Now you want to get rid of log base 10, so I say you raise them to the power of 10, both sides. Now I'm doing this because I want to use this property here. Then I have this one here, x times x plus 1, x times x plus 3 is equal to 10 to the first power, which is 10. And then I can do the rest. So I can solve this equation, right? Let's follow the slide. Okay, now this makes this, okay. Now it doesn't directly, if you think of it, the base is 10, you can say 10 to the first is equal to this, or the common thing here is to keep, you like this type of thing, so I will show it to you this way again. How do you eliminate 10? You raise them to power 10. Then we have this. Okay, so it makes 10 to the first power. And we have the similar thing here, like log based. Now, yeah, we do the reverse sometimes, like for the exponentials, you will remember it. Anyway, we got this one. And now we solve it. And again, after finding the solutions, we have to do what? We have to check the solutions. Okay, check the solutions here. Put them in the original equation. Log minus 5. Is it acceptable? No. No. Here, this is negative inside the logarithm, and this is undefined. So if it is undefined, so this equality doesn't count as true. So this is not true. The solution x equal to minus 5 is extreme solution. It's not a solution. Now check for 2, everything looks fine. And then we have positive here and positive here. All terms are defined, so the solution set is 2. Now let's look at these two problems here. 7 ln x equals to 21. Okay, guys, if you don't have like any ln terms here, you can directly go ahead and try to do like 7 here. And how can you do it? You basically say ln x, like divide by 7, divide by 7. So it will be ln x equal to 3. And then how to get rid of this ln? I mean, I want to remind you this. Log base e of x is equal to 3. And e, raise them to e's power. Then log e and e cancel out, and you get x equal to e cubed. Now, I know some of the students, they try to do it this way first. Okay, that's also another way of solving it. This way you will come to 21 and raise it to e to 21, and then there's a cancellation here, and we end up with x to the 7 equal to e to 21. You take the 1/7 power of both sides, and we end up with e cubed is equal to x. Same thing. But, you know, if you do such thing here like this, it will make it a little long, okay? So we will get rid of the unnecessary calculations if you do it this way. We generally do this everything ln. You know, we put this inside. If you have something like ln in the other side, if you don't have ln equal to ln, no need to do such thing. Like no need to take 7 inside and write it as a power. Just go ahead, you know, raise it to the power of e. Now look at here. So how can I do this one? You know, first you can say what number should it be. You can say it's 4, but I will use the way you like it. How can I get rid of 4? Raise them to the power 4. I mean, not power 4, the power of 4 as a power of 4. And then log base 4 and 4, they cancel out. You get x cubed is equal to minus 6 equal to 4. And then x cubed is equal to 10. And then x cubed, you take 1/3 of both sides, and you know, 10 is odd number. No, 3 is odd number. So we say just x is equal to like 10 to 1/3. So this is the solution here. And I think it's the end of the video. Okay, thanks for watching. Please, in order to get the depth of the topic, please do practices and try to solve the additional exercises. I'm sure you will solve the worksheet with your instructors, with your teachers, but in order to get a very good grasp of the topic, I strongly recommend you do the additional exercises. Do them, please.